we've already talked about while loops, so I think we don't need to spend a lot of time on it, especially if you've ever done any programming before. The vast majority of y'all have. This is just a reminder that one way you can get data in, and not just from the keyboard, but even reading in data from a file or something like that, is with a priming read. Priming read, you have to do your first little bit of data, and then inside the loop you get successive elements. That's not absolutely the only way to handle it, but it is one way. My favorite way of doing user input from the keyboard or something like that is to instead use a while true loop with a break. Once they enter the sentinel value, then that bails out of it. I don't think the textbooks typically show that, but that's okay. Then there's the do loop. You Python folks haven't seen this before. It does not support a do loop. The vast majority of y'all who've taken Java or something like, well, wait. Let me rewind that. If you've taken C++ or another C-based programming language, you've seen the do loop. Probably. It's what's known as a post-test loop rather than a pre-test loop. So you have while, condition, and then you do stuff, right? This is pre-test. Pre-test meaning that this has to be true, and the test occurs before you enter the code. Then there's the other kind. Do some stuff, or whatever the stuff is, and I'm pretty sure we already talked about this because I think Lynn asked if there was a do until loop. But anyways, do while condition, right? So in this case, it's a post-test loop. So pre-test loop, condition is first, and if the condition is false to begin with, nothing happens. Post-test loop, stuff is done, and then the condition is checked. So the stuff always happens at least once. My brain doesn't really think in terms of do loops, and as far as I can think, there's really nothing you can write with a do loop that you can't write with a while loop. But you might have to kind of monkey with the syntax and use while trues with breaks or something like that. So I'm sure that there are a great many times when this is the most appropriate way to structure it. It's just that my mind is so happy to run with while true and then break statements to decide when I want to leave, that that's typically how I write this stuff. You can mimic a do loop just by making sure that the condition is true the first time. And I think y'all have seen me do something like that, where I do this. I give it a condition that's true. So if they're supposed to type in -999 to quit, I type in a number that's not -999. And then I have while x is not equal to 999, do some stuff, right? Or, input x. And if x is not if x is not equal to 999, do some stuff. That is exactly the same as a do loop. X is equal to 0. Do this stuff. Input x. If x is not equal to 999, do something. Exactly the same. And I'm sorry about repeating the word do there. That makes it look like, it's valid syntax. That's why I say that there's nothing you can write with a... Oh, I forgot to put my condition. Repeat this stuff while x is not equal, while x equals, not equals 999. Something like that. One little notice about the syntax is that I keep saying that you don't put semicolons after while statements or if statements or for loops or whatever. Here you do put one, because that marks the end of this. That's just a little kind of syntactic oddity. You do got to put a semicolon after the end of the entire do structure after the word while. Whereas if you put a semicolon there, it breaks it. And you just have to kind of accept that. I don't know that I need to actually give an example of that. This is just an example showing that you can accomplish the same thing with a while loop as a do loop, as shown below. Which is why Python doesn't have one, right? Because if you don't have to have it, it's a duplicate functionality. Well, like I said, I'm sure that there are times when the solution is more elegant if you use a do loop. And here they say that proper style dictates putting the while part on the same line as the brace. All right, fine. I guess I did that just by matter of course, but you know, if you did that, would I yell at you? Nah. I guess they don't like it like that because it looks like that's a broken while loop, you know. But like that, you can instantly see that it's, you know, part of the loop that's up above. So problem description, architecture design program. There's going to be a main method. We're going to ask for the length and the width of each room in a proposed house so that the total floor space can be calculated. After every length and width entry, ask the user if there are any more rooms, and then print the total floor space. So pseudocode for that. Right. Enter length. Enter width. You know, calculate, you know, floor space is equal to length times width. And then, you know, ask user for, you know, repeat is equal to input. And I'm just looking at a Python here, or whatever. Print okay, I'm going to give it and do it in Java. Print repeat yn. And then input, you know, choice. And then we would do keep repeating this stuff while choice is equal to y. Something like that. And if we wanted to do our proper Java syntax, we put that in parentheses. You know, and again, this is a mixture. This is a horrible mixture of pseudocode and Java, but that's okay. For this to work, we have to have this variable declared to begin with. I think that's true. Yeah, because this is outside of the range of the scope of that. So I'd have to come up here and create my variable to begin with, right? Choice, string choice. And if I've gone that far, then yeah, I could do, you know, choice is equal to scanner.next, right, or next line. Something like that. This is still wrong, right? But we get the idea. Okay, so we have this little program, and after one iteration of the loop, we ask them if they want to repeat. If they do, great. It'll hit this, check this condition. This condition is true, it'll repeat. If it's not, it'll fall out of the loop. So many other ways you can implement that, but yeah, that works. I'm not really planning on asking y'all to write a lot of do loop code. For loops. For loops are the best loops ever. These are the loops that you're going to love. Honestly, you don't ever have to even write a while loop if you write because there's nothing you can write with a while loop that you can't duplicate with a for loop. There's nothing you can write with a for loop that you can't duplicate with a while loop, but the for loop has a really awesome syntax. That said, the while loop also has an awesome syntax if you're doing the task for which it's designed. If that's not a way to put it. There are some things for which for loops are really designed, which is counting or iterating through something. If you know, and they say this, if you know the exact number of loop iterations before the loop begins, well, that's not the case. That's not the only time you use it. You may not know the exact number of loop iterations. But if you're looping through a series of values, that's when you use a for loop, right? If you're going to count from 10 to 1, great, use a for loop. You know, if you're going to iterate through a series of items in a list, use a for loop. If you already know, you know, if you have a defined series or a defined set of data, then you probably want to use a for loop rather than a while loop. We'll show the syntax for that in a minute, but I'm going to write a few little guidelines that the book gives us at a certain point. And I think I've already said this before in an earlier chapter. Use a do loop if the body of the code of the loop must be executed at least once. All right. Use a while loop if the number of times to repeat is indeterminate. You know, we don't know how many lines of code, you know, we don't know how many values we're adding up, right? We don't know that there's only 10 values every single time. We don't know the length of the file, something like that. But, okay, that's different than how this book says it. I'm going to push this down, and I'm going to say use a for loop to count over a series or a list, something like that. And then use a while loop if the number of times to repeat is indeterminate, or you could just say use a while loop otherwise. All right, what's our for loop going to look like? I'm sure we've already done this, have we not? For int x is equal to 0, x is less than 10, x plus plus, system.out.print line x. It's just going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is this a pre-test loop or a post-test loop? Does it always execute the body of the code no matter what?
No, it's a pre-test.
Right, it's a pre-test because if this condition wasn't false to begin with, then it wouldn't run the body of the code. Well, when would that be? Well, what if we set up our loop inaccurately, right? We did that. X is equal to 90. X is less than 10. Is it going to print anything? No, it's not, because it checks the condition. It may not look like, you know, but it does. So the order in which these events happen is that happens first. That assignment happens first, that initialization. Then the comparison is done. If the comparison is valid, then it does that. Then when it hits the close brace, it comes up and it does the increment. Kind of odd. Blip, 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 right? You know, maybe in some other, you know, universe, somebody has written, you know, something like this that has the x plus plus, you know, at the end rather than the beginning, because you think that that's the last thing that's supposed to be done. But we just accept it. It's a pre-test loop. The update gets executed after the body. So if you write a while loop, usually you have to initialize something. Yeah, you have to initialize. And then you have a condition. While x is less than 10. So that's the comparison. And then you have something that you do. So that's the body of the code. And then you have an update. That's a typical while loop structure. Even if it's completely different, right? Could be open file and then while file has data, do some stuff. Or it could even be while true. In that case, we'd probably skip the initialization. But yeah, that kind of thing. That's the typical structure of a while loop. We have an initialization, a comparison, and an update. The for loop, for initialization, well, here I'll write it out. You know, for x is equal to 0, x is less than 10, x plus plus, do some body. And so here we have the init stage, we have the comparison stage, and we have the update stage, all listed in one line. But there's nothing you can write with a while loop. going to be doing if we were going to sing Beatles songs. That can't be done with a for loop. Nothing that you can do with a for loop that can't be done with a while loop, because they are just the same exact thing. It's just that this is a really nice, concise syntax for processing it. I hope that makes sense. And so if you were going to make a while loop that was going to count from 100 to 10 by -5s, you could do that. For x is equal to 100, keep running while x is greater than or equal to 5, and then x minus equals, wait, I said from 100 to 10. X minus equals 5, and do something. System.out.println x, right? Count from 100 to 10 by -5. This is the same as a Python statement for x in range, setting it equal to 100 to begin with. Keep going, but unfortunately, the syntax is a little bit different there. Like that. And in a way, maybe that's even cooler to you, maybe not. But I like being able to express my stopping point with an entire expression rather than that. And why 9? Because when you do it in Python, you have to define one past the endpoint. So this would count down to 10, but then when it was 9 or less, then it would stop. So that's about enough of that. If I wanted to make it match exactly, I would do this. Right. That would make it count down from 100 to 10 and then exactly match the Python syntax. It's just that Python does not do greater than or equal to for that one. It just does greater than. Whatever. I like greater than or equal to. That's the way my brain works. If it was really Python, we would put a colon here and we would indent our print statement. All right, there. All right. Okay, so going back over here, find the factorial of a user-entered number. Enter a whole number, 4. 4 factorial is 24. Factorial just means 1 times 2 times 3 times 4. That's a defined series, right? It's a series of numbers. So that's a perfect use for a for loop. We can do that. I could even make y'all do it together. I haven't made y'all type in anything yet. Taking C++, you know how nice it is to not have to copy and paste that boilerplate each time. Alright, so I'm going to delete the package. You don't have to do that. You could also delete it after you create the file. Or you don't have to delete it at all. It's just a little slightly easier for me to grade it if you do. Put my name at the top. Read demonstrations. Alright. I'm going to comment out the fact that these are the command line arguments because we really haven't been doing a lot of command line arguments. In fact, we've been doing none. Alright, so calculate factorial from 1 to x. We should ask the user for x. That'd be more fun, right? Why don't we write this in the form of a method where we pass in x and then we return the factorial? So, like I've said last time, if you're inside a static method and you're calling another function, another method in the same class, it also has to be defined as static. So that I do want this to return an int. I could even make it return a long because factorials get huge very quickly. But make it return an int. And I'm going to call it factorial. And as an argument, it's going to accept x parameter. I'm just setting all this up so that we can write a for loop. Maybe instead of x, I could give it a better name, like limit. Now this is supposed to, I'm going to put a comment here. Calculate the factorial from 1 to limit. Better yet, calculate and return the factorial from 1 to limit. So whenever you have some kind of loop that's performing some kind of accumulation, you know, addition, factorial, whatever, you need to define your variable before the loop so that you can do something with it after the loop. So, int fact is equal to 1. I didn't make it 0 because if we made it 0, 0 times 1 times 2 times 3 is going to be 0. So we have to start at 1. Alrighty. And then for int v for value, I for iterator, n for number, doesn't matter. For int n equals 1, n is less than or equal to the limit, and each time we iterate we want to add 1 to n, and then fact equals fact times n. And is there a different way to write that fact statement using a compound operator? Anybody wants to iterate?
Times equals.
Yep, Daniel knows. Everybody else is shy. Fact times equal n, like that. All right, and then we return fact. If this was summation instead of factorial, we would start our accumulator at 0 and we would just add to it each time. Plus equals. And I'm 1,000% sure that that code is correct, barring syntax errors, so I'm not going to even write test code for it, you know, ask the user for it and stuff like that. Unless we need an example of calling it. But once you get that, we could go down to main and we could call it. So the first line of main, int result is equal to factorial of 10. And that'll be 10 9 times 9 times 8 times 7 times 6, whatever. But like I've said, factorials get huge, dramatically huge. And so storing the result in an int isn't going to give us much playroom. We ought to store the result as a long, or even better, a double, whatever. System.out.print line, quote, factorial of 10 is space, end quote, plus result. Why write the code if we're not going to test it? All right, factorial of 10 is 3 million. Right, that's sure to get huge. What's that saying on the internet? That escalated quickly.
Try it with 100.
Yeah, if we try 100, it's going to be larger than it'll fit in an int. It says 0. We could put this in a loop and we could test it. You know, where this was a variable that kept incrementing. Let's do that. Let's say that we're really awesome and we want to write a loop that's going to keep running. So I feel like using this result variable to hold my answer so that I can do this. So I'm changing it a little bit. I'm going to use while result not equal to 0, because once it hits 0, that means that some overflow has occurred. And then inside, well, maybe I should have set this up as a for loop. I'm going to do that. Let me rewrite this as a for loop. For, I'm sorry to keep changing it on you, but if we're going to write it in a for loop, we don't need to define our result above the for loop. We can do it as the first thing inside the for syntax. So for int result equals 0, keep running. I wish I'd done it the other way now. For int result equals 1, keep running while result is not equal to 0. And we don't even need to increment anything. That looks weird. But we really don't need to increment result because result is calculated. And so inside here, we say result is equal to factorial. And I definitely regret my decision to make this a for loop. It should have been a while loop. You'll see programmers who like for loops pervert the syntax of for loops like this all the time. And what do I mean by that? We left off the update here. We could have left off the beginning of it. If I cut that, pasted it, put that there, put a semicolon there, all right, this for loop is looking even stupider now, right? But it works. It's just that there's no initialization to be done. There's no update to be done because all of that stuff is handled inside it. So should this have been a for loop? No, we should have written this as a while. While result not equals 0. Now that I've done that 20 times, I'm just going to change it back to what it should have been. While, parentheses, result not equal to 0. Right. I was doing that to kind of show you that for loops, the various pieces of the header are optional. You don't have to provide an initialization. You don't have to provide an update. You don't even have to provide a comparison. If you leave the comparison off, it's the same as a while true loop. Kind of bizarre, but that's the way it works. So you could write a loop that just said for something, semicolons, or nothing, semicolon, nothing, semicolon, in parentheses, right? It looked like this, and don't type this because I'm going to delete it. All right, and you can if you want to. For, you know, dot, dot, like that. It's the same as while, parentheses, true. Why would you use one over the other? There's no argument for using one over the other. That looks so ugly, I may be tempted to delete it, but whatever. Okay, so now we're going to run the code, and at the point where overflow occurs, hopefully result will be set back to 0, and this code will stop. If not, we may have an infinite loop. Let's find out. Oh, it is going to be an infinite loop, or it's going to break. Okay. I forgot that I actually wanted to put a number here that counted from 1 up to whatever. So a for loop would have been adequate after all. We're going to rewrite it again. How about that? For int n is equal to 1, because we're going to start with the factorial of 1. And then keep going while n is less than or equal to 100 and result is not equal to 0. And then n plus plus. Then I need to change that 100 down here, my argument, to n. So I'm going to change that next. All right, might work. When I run it, well, factorial of 10 is blah, 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 blah. Obviously, that's wrong, right? I should have printed out in there. At a certain point, it goes nuts. It looks like overflow probably occurs
Well,
from there to there. I don't know how to check for that. It never equals 0. At a certain point it turns 0, and at least it stopped there, but overflow happened long before that. Whatever. But we can, if we change this to actually print out the value of n there, then we will see at which point it started to go off the rails. So my print statement needs to be modified a little bit. Maybe I'll use %d. Yes, sir.
Can I catch up?
Yep. Let me get back to the code. I want to make that last change to it. And while I'm making that change, okay, then I'll come help. So, I'm going to change this to a printf. I'm just going to comment that out. System.out.printf, parentheses, factorial of %d is %d backslash n, end quote, comma, n, comma, result. That'll look better. Okay, so I paused the recording. I know Vincent needs to watch this. I made a few changes to formatting. I put the braces on the above line using the K&R brace placement. And I took out the braces around this. Pause it if you need to. And then I'm gonna delete this print line statement. There we go. I think we're good there. I think we got it all. All right. So we did have a use for a for loop. I'm sorry that I waffled and I went from a while to a for back to a while. When I started that little journey, I remembered that I was going to have a variable iterate, keep counting. That's when you want to use a for loop. Could I have written this as a while loop? Yeah, absolutely, right? One thing to note here is that unlike some languages, like Python, for example, this condition here doesn't just depend upon this loop control variable here, right? This is a more complex expression. Yeah, sure, we're counting up to 100, but we're also making sure that our answer is never equal to 0. Maybe we could change this to while our result is greater than 0, and then it wouldn't run quite as long producing garbage output, but it's still gonna. I am curious as to how to write this in such a way. I'm curious to find out how to know when the overflow occurs, like if there's some function I could call. Obviously no exception is being generated if overflow occurs. So it's kind of a silent error. I don't really like that. How do I know it occurs there? Because it's been increasing by a huge amount each time. Oh, maybe it occurs from there to there.
No, it occurs up a line.
Yeah, because it actually
Goes
gets
down.
smaller.
But it actually go up between 12 and 13. That's what it really was.
It gets a number bigger between 12 and 13 though.
No, but
But we're not exactly sure. Right, we would have to multiply this by 13. But let's go find out. My curiosity is stoked. Is that number greater than 2 billion? It sure is, so Matthew's right. Yeah, that's where the overflow actually honestly occurred. So what we could do, if we cared, and sure, why not? We could check fact to see if it was too large to fit within an int. Well, how would I do that? We'd have to store it in a long, and then we'd have to compare it to a constant, which was the maximum value of an int. And if it was, then we might return a 0, right? Otherwise, we would return fact cast to an int. Or we return this as a long, right, so that we avoid the problem for a while. That's worth doing. That's worth doing. We're going to make factorial return a long rather than an int because this number gets really huge. So we're going to have to change some occurrences of the word int to long in a few places. Not that many, though. Do I need to change this to a long? And my answer is no, because ints, factorials get so large so quickly that the largest number that we can hold, the largest argument we can hold, will still fit under 2 billion. But we do want to change that to a long. And if we're going to change that to a long, what else do we need to change to a long? Because what are we returning?
Fact.
We're returning fact. We're saying that we're returning a long. So what needs to change to be a long?
The int in front of fact.
Right, we got to do that. Now we need to make one more change. What variable do we store the return value of the factorial function in?
Result.
Right, in fact, it's already yelling at us here. Incompatible types.
So that's good.
It's offering to cast it, but that's a stupid way of doing it. So don't always just accept their solution. Think it through instead. And in this case, the problem is that if we're returning a long, we should store it in a long. All right, now the number's going to get considerably larger. It's gonna certainly run past 12 and 13. All right, so it got to 20, maybe, before it blew up.
And it can be shown that 20 is the limit.
What happens if it went past?
Also,
You've just postponed the
now
problem.
I can't seem to get this new one to run.
Okay, I'll come help. I'm sorry, what do you mean by postpone? Yeah, right, it still blows up.
Yeah.
Well, we could make it return a double. Doubles hold vastly larger numbers. But what we would have to do is we would have to change that to double. We would have to change that to double. We would have to change that to double. But there would be one more change we'd have to make, which is here. Because when we print out a result, we don't use a %D if it's a double. I wish we did, D for double, but that's not. D means int. What do we have to change that to
If we
if we're
just
printing
turned
out a
it,
double?
first we made them floats only, and then doubles.
Yeah, yeah. So a float would work, and then a double would work. Why not? Let's make all these changes, and then I'll come help you, Dano. We're gonna make this return a double. We're gonna skip the float step. We're gonna declare our variable as a double because that's what gets returned. So I've changed that. I've changed that. In fact, everywhere that the word long occurs, I'm gonna change that to a double. And then here, when I print it out, it better not be %D, it better be what?
Percent F.
Right, because it's a floating point value, %F. So I changed all those longs to doubles, and then I changed it to %F. And then I'm gonna run it, and then I'll come take a look at everybody's screens. Woo boy! It got all the way to 100. We're gonna have to try a larger number. Let's try up to 1,000. So I'm gonna increase my for loop limit. Okay, eventually it got to infinity. All right, I wonder at what point.
171.
All right, there we go. So we got a larger factorial. We got a much larger one. This is a huge number.
Point, yeah, okay.
If we printed it in scientific notation, we'd see the exponent. And so I feel like trying to print it in scientific notation, and I believe that the %F can be changed to %E, and that would print it in exponential notation. And now when I run it, it still says infinity, but maybe at 171 it doesn't. Okay, I need to change this 1,000 to, 120 or something, so I don't have to scroll back up. That's silly.
200.
Yeah, 200 sounds good. All right, there we go. And there we go. See, that is about the limit of a double, a number to the exponential of 306. A digit followed by 306 zeros. It's about the limit. Same time. So that works too. Right, just print out n times n, that would work. System dot out dot, and you don't change your code to match mine, right? Print n times n, that would do it. Rather than storing the result. Like I said, don't change it if you didn't do it that way. Alright, so loop comparisons, and this is just what I said already. If you know prior to the start of the loop how many times you want to repeat the loop, in other words, you're going over a definite series of numbers, or a definite list, then do that. If you always need to do the repeated thing at least one time, use a do loop. And if you can't use a for loop or a do loop, I think I would just say otherwise. Because you can always use a for loop. You already saw me twist the syntax of the for loop in such a way that it's just identical to a while loop, but there's no reason to mess it up like that. So, those are the three things, and I think I worded that pretty close to that, so I'm not going to copy and paste that into the notes. So a nested loop is a loop within a loop. Write a program that prints a rectangle of characters where the user specifies the height and the width and the character's value. Did we already do nested loops? Feel free to say no.
From what I remember, I don't remember it.
Okay, cool. So nested loop, you have an outer loop that's controlling one variable, or maybe it's just asking the user if they want to repeat. And then you have an inner loop that's controlling another variable. So a nested loop could be as simple as this, right? While, and the user wants to continue, right? Do something, and then inside that you have for int I is equal to blah, blah, blah. That's a nested loop. We have nested loop here, right? We have an outer loop here, and we have an inner loop there. Technically, that's a nested loop. Or maybe you do this. For, I is equal to something, and then inside the body of that loop, you do something else. For, j is equal to something. And then inside that one, you do something. Whatever. I'm going to write some code, and I'm going to ask you to predict what it prints before I actually run it. No fair running it to see what it does. I can't stop you. All right, so maybe down here at the bottom of my factorial, I'm going to put some comments here to help me keep track of things. This is the end of the class. This is the end of main. And I want to stick my code above the end of main, since I'm putting it at the bottom. All right. So for int I is equal to 0, I like x and y. X is, maybe make it 1. X is equal to 1, keep going while x is less than 10, x plus plus. I'm going to make an inner loop now. For int y is equal to 1, y is less than or equal to x, y plus plus. And then inside here, I'm going to print out an asterisk, but I'm not going to make it print line. I don't want it to go to the next line after every asterisk. I want it to print a row of asterisks. But once we're done with that row, then I'm going to print a character term, so print line there. All right, if you eyeball that, maybe you know what it's going to do, maybe not. Anybody have a good guess, or even a bad guess? If we were going to dissect it, I would say that this is probably going to print out a row of asterisks, and then hit the enter key, and then print another row of asterisks and hit the enter key. And keep doing that until the outer loop was done. Because the way nested loops work is that the inner loop has to finish. It has to run and run and run, and then the outer loop increments once. And then it repeats the inner loop, runs all the way again. And then the outer loop repeats once. It's kind of like if you ran a marathon every day. So, you get up in the morning, that's the outer loop, and then you run your marathon, and you go to bed. Now it's the next day, that's the outer loop again. You go back in, you run, your marathon again, you exit that, inner loop, and you're ready to go to bed, and you wake up again. So you do this inner loop, it starts and it begins, and then it iterates the outer loop again. All right, so somebody just run it and tell me what it prints.
Like a rectangle.
Triangle.
It actually is a triangle, and a rectangle is an exceptionally good guess. I could easily make it a rectangle, but why is it a triangle? What is it doing? What part
It's
of this
just
code?
an x, so it's saying y equal to x, which is incremented.
Yeah, you see that? What does x equal the first time it goes in the loop?
1.
Yeah, and then it equals 2, and then it equals 3, and equals 4. So this row is the same length as x, or it has that many columns in it. So the first time it iterates this loop, it's just going to count 1 asterisk and hit enter. The second time it iterates the loop, it's going to print 2. If I wanted to change it to make it print a rectangle of exactly 25 wide each time, what would I change?
You would change the x to 25.
Yep, right there. I would change that to a 25, and that way the inner loop always prints 25 asterisks. Pardon me?
It doesn't mind that you're not using X within the,
Right, just like if I had something that was, press Y to continue, some kind of choice variable, I don't have to update choice inside the inner loop. I would update choice, at the end, after the inner loop is done. And I don't know whether to make this an assignment or just demonstrate it to you.
How about the letter?
It's kind of like we already have a lot of homework coming up. So maybe I won't assign this to you, but what I'm wanting it to do is to print a multiplication table. And so we're going to have a certain number of columns, and we're going to have a certain number of rows. And I want each element in it to, represent the product of those. Easiest way to do that would just be to copy and paste this code. Let's save ourselves some typing time. Copy that, paste it. All right. I feel like just going from 1 to 10, that's enough, right, for a multiplication table. But here I'm not going to print out asterisks. What am I going to print out there?
X times Y.
Yeah, let's print out x times y. And that's not going to be the perfect solution, but it's a really good start. Okay, yeah, it's working, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6, 8, 10, 12, all the way up to 20. But we could format it better than that. We could use a formatted print statement. Make it look prettier. So to make it a formatted print statement, I have to change a couple of things, one of which is I have to change that to printf. And the other is that I need to provide a formatting string. So I'm going to put a string there. And inside the formatting string, I need to use a % sign, and then I need to specify how many columns wide I want each element to occupy. Somebody tell me how wide I ought to make my columns. And we're just going to experiment. If it's wrong, we'll change it. So %, I'll just give you a blue sky number. 10, 2, 3, how many spaces do we want to allocate for each result in our table?
Maximum of 3.
Yeah, let's try 3. So %3f, because we have floating point numbers. No, we don't. These are ints. %3d. Now when I run it, 3 was perfect except we got here. And I wish it would just push it over, right, to the 4th place. But the far easier fix would be to make it 4 wide. Yeah, that worked.
There'd be no easy way to left align it, would it?
You want to left align it rather than a right. We would want to left justify it. The way you left justify it is you put a minus sign after the %. That means left justified rather than right. But there's no cute little thing there for centering it, and I wish there was, right? Take my number and center it. That'd be neat. I don't know why they don't provide it. But okay, now it's left justified rather than right. We all good on our multiplication table?
So, well, here's what I tried when I did.
Oh yeah?
This is what it looked like.
That would do it as well, but they're not lined up perfectly. So to get it to line up perfectly, you are going to have to use a printf.
Which is what I have right here.
Right, but you don't have a formatting string. So why don't you go ahead and do it this way, rather than bang your head on it to get it to work a different way. But I like that you're exploring it. Just revising it. The thing you can remember about nested loops is that the inner loop has to continue, iterate, it has to complete before the outer loop will iterate once. And so this is printing an entire row of numbers. It prints out the first row of the multiplication table and then the second and so on. Boolean variables. Seems like an odd thing to jump to after loops. A Boolean variable is equal to true or false, and it stores the result of a calculation, a Boolean expression. Something like this. You know, I'm pretty sure I've done this before, but I get confused between this and the C class. Boolean frozen is equal to temperature less than 32. Like that, right? And then you can do if frozen. Do something. They're also known as flags. So Booleans hold true or false values. And for you guys taking C++, remember that it's bool in that language and Boolean in this one. Yeah. And people call them flags as well. Kind of like a motor race flag, right? You're waving the flag just to say when to start, and you wave the flag again to say when it's going to stop. That's typically what you do with it, though, because you store some value in it, and then you make a decision based on it. And if whatever the decision is, it could be an if statement, it could be a while statement, something like that. How about this? Boolean frozen is equal to temperature divided by 32. While frozen, add 1 to our temperature. Keep warming it up. And then repeat our expression, right? Eventually it would stop. So this does follow our basic structure for while loops, right? That's our init, that's our comparison, and that's our update. That make sense? I saw foreheads nod. Makes sense for everybody?
Or distracted.
You good, Lynn? Feel free to
Are
say
you
no.
putting something in temp and then trying to see if it's less than 32?
Right, we would have to get our original temperature, right? Input temp. You know, read it from a sensor, ask the user for it, whatever. Temp is equal to in.nextInt. And this would keep raising the temperature until the temperature was no longer less than 32. That make sense? Okay, cool. So if you're writing a program that simulates the operations of a garage door opener, and most garage door openers just have a single button. It indicates whether it goes down or whether it goes up. So you would need to keep track of the direction state. The direction state determines what happens when the button is pressed. So if the state is up, it needs to go back down. If the state is down, then when you press a button, it starts going up. That's almost a little too abstract for me, but okay. So if we have a Boolean variable, the direction values for the state of the opener direction, and then the associated values for the Boolean variable named up direction. So we're going to declare, whoopsie, where did that come from? Go back to the beginning.
No, it's like.
Oh, it went to the next page. Okay. So anyways, we have a Boolean variable which we have decided means up if it's true, but if it's set to false, it means it's going down. Now to me, this has all kinds of questions, like do we need another variable for whether the motor is engaged or not, right? You know, run motor, you know, motor running equals true as well. And then when it hits the bottom, then you'd set motor running equal to false, and then you could change the direction, something like that. Well, I'm not going to think through their example too much. and they sure do talk about it a lot. So Boolean logic is the formal logic that determines how conditions are evaluated. We've seen the operators for it, and, or, and not. Our review. And requires both sides to be true, or one or the other side or both can be true in order to trigger it, and not reverses it. And I think I figured out for the C++ class, did I talk about De Morgan's law a lot last class? Tu's going to nod yes because she went C++, but nobody else did. If there is a mathematical law that says that, right, if you have this x, y plus z, and you expand it, it becomes xy plus xz. And I know I've mentioned De Morgan's law once, so if you're looking through your notes to find it, you are going to find it. The same is true of something like this. You can expand this, but when you expand it, you might think it's going to become not A or not B. But De Morgan figured out that it actually is not A and not B when you expand that, and vice versa. If you have not A and B, that is the same as not A or not B. And this explains, once you talk about it enough, why to check within a range, you use and to check outside of a range, you use or. So for example, if the temperature is greater than equal to 32, or just greater than 32, and temperature is less than 212, freezing and boiling, then it's, then it's liquid. If you want to check to see if it falls outside of that range, you flip the signs. If it's less than, I forgot my 32 then. If it's less than or equal to 32, or it's greater than or equal to 212, then it's not a liquid, right? It's either frozen or boiling. These are just the opposite of each other, right? It's either a liquid or a not liquid. So you could do this. You could take this liquid expression and just not it, right? Because that's what the not symbol means. So if, parentheses, not this, then it's not a liquid. Right? We agree? Because this meant that it was a liquid, so if we put a not in front of it, it means it's not a liquid. Well, this looks like something we could expand with De Morgan's law. And the way we do that is we have to replace the logical operator with its opposite. If it's or, it becomes and. If it's and, it becomes or. So if we were going to rewrite this, it would become, and it's going to become simpler. At first, it's going to look like it's more complex. If not t greater than 32, or not t less than 212, it's not a liquid, right? Following De Morgan's law, which we will prove by doing this that it works. That is the expanded version of it. Now this hurts my brain. If not t greater than 32, what's another way of expressing that? Well, what's the opposite of greater than? It's not merely less than, it's less than or equal to. And the opposite of less than is greater than or equal to. So if I wanted to rewrite this and take away that, I would change that to a what?
Less than or equal.
Yep. And I would remove that and change that to greater than or equal to. And now I have a whole bunch of superfluous, right? And this expression and this one are the same. So you can use De Morgan's law if you want to simplify your expression. If if you were given this expression and that hurts your brain to look at, which it does mine, then by working through it, you'd be able to rewrite it like that, and it would look a lot simpler to me. But there's always other ways, right? You could do something like this. Liquid is equal to, and you use this first expression. You know, so Boolean liquid is equal to that. And then you could do either if liquid, or you could write another one that said if not liquid. Storing your Boolean expression as a flag, and then basing some decisions on it like that, if you give the Boolean variable a good name, can make your code easier to read, right? It's up to you whether you think that's cooler, or whether you think that's cooler. This expression is not so horribly complex that if I worked with you, I would insist that you should have stored the result in a flag first. But I think that does make it easier to read myself. Your opinion may be different. And now we really are up against the time limit. I think we've done enough with loops that I don't need to assign any more homework on it. So why don't we just pause? Are we at the end of the chapter? We better be, because we said that an exam is coming up. Yeah, we really are. There's our summary.
Yes.
What Java operator reverses the truth or falsity?
C.
Yeah, not. Which one provides multiple branching?
Switch.
Switch.
Certainly not option or shuttle. And which Java loop statement has 3 components in its heading? 4. Yep, all right. So we made an A on our exam here. These are a little too simple, right? Okay, that's why I write my own
Now we
quizzes.
don't have to do the quizzes, we can, right?
You gotta do the quiz. Get the quizzes done as fast as possible, and I'll get them graded for you as fast as possible. I'll keep checking them each night.